All right, so ladies and gentlemen, here we go. Looking at our proofs, yesterday we spent a lot of time getting down the algebraic properties of equality. With today's lesson, we're going to be using those properties again, but looking at them from a geometric point of view, which is the purpose of 7, 8, and 9 from your homework last night. It's time to look at those algebraic properties, but again, we're looking at it from a geometric point of view. So when we look at our proofs, when we look at geometric proofs, they're really non-intense. The thing that you guys are going to struggle with the most is basically the definitions. And we have a lot of properties, and we have a lot of definitions. And it's really important that we just kind of do our best to get those under control and try to do the best of those that we can. So one of those that's just really kind of an odd one to talk about is this concept of congruence versus equals. And the best way that I can describe it for you is that we have congruence, and the congruence symbol is not weird or anything, it's just really basic. It's an equal sign with a tilde on top. That means congruent versus equal. And here's the problem. You can't do any math with congruence. You can't do any math with congruence. You can't take two congruent things and multiply them by 2. You can't take one congruent thing and add it to another congruent thing. So you can't do anything with it other than stating that it's congruence. So what we do is we transfer those properties of congruence to equals. And anytime that we switch, make this a big note in your notes. Anytime we switch from congruence to equals, we call that the definition of congruence. Anytime we switch from congruence to equals, we call that definition of congruence. And we're going to see how that kind of works out in our proofs. So you might want to make a note that anytime we switch from congruence to equals, we call that definition of congruence. Now, the next thing we've already seen before in this class, segment addition postulate. What does that mean?
The sum of the parts equals the whole.
The sum of the parts equals the whole. That's it. So anytime we add up the parts and we get the whole, again, we're adding up the parts of a segment. That's going to be segment addition postulate. So what are my parts?
AB plus BC.
So AB plus BC equals AC. So anytime that I add the parts and I get the whole, my reason, this would be my statement, my reason for that statement would be segment addition postulate. So what if I was adding the parts of an angle? What do we call it then?
Angle addition.
Yeah, that'd be the angle addition postulate, which is actually the next thing we're going to talk about. So here's the proof. We're going to prove that AC is equal to XZ. Very, very simple proof. Yeah, if you want, I would. Okay, so we're just going to add up our parts and get our whole. Alright, so our given statement. AB is congruent to XY, and BC is congruent to YZ. If I were you on a lot of these proofs, I would actually take notation with this. I would make marks on the diagrams. So we're told that AB is equal to XY. So those two are equal. And then we're told that BC is congruent to YZ. Okay, what are we asked to prove?
Prove AC is congruent to
AC is congruent to
X.
Z. That's what we have to get to, guys. That's your final goal. All right, here we go. First line of any proof is always
Given.
Given. Alright, we should have no problem with that one. That's given. Well, what do we call it? I don't know. So what changes from line 1 to line 2? Again, what's going on? We go from line 1 to line 2. What changed? Cheyenne? Yeah, so what happened? Okay, so again, anytime we switch from that congruence to equal, what do we call that? Definition of congruence. So let's just abbreviate that, okay, and we'll just call that def of con. It's okay to abbreviate. I know not everybody agrees with me on that, but it is okay to abbreviate. Definition of congruence. Please make sure that you actually know that that means definition of congruence. But def of con sounds better. All right, take a look at number 3. Look at the statement. What's happening? AC is equal to AB plus BC. What's happening? What's that telling us? What did it do? Is it related to line 2? Okay, so not every line is going to be related to the line above it. So what's happening on line 3? Cheyenne?
They're showing the segmentation calculate for A.
And a lot of times when we're doing proofs, guys, if we go back to the proof statement, what are we trying to prove?
The AC is congruent.
Okay, so it might be helpful if we actually understood, well, what is AC? So once we've gotten past our givens, we then go down here and take a look at line 3, and we say, okay, fine, let's start defining this. What is AC? Well, AC is AB plus BC. It's adding up the parts of the whole. Segment, addition, postulate. Seg post. Well, this is the hard part of the proof too. Going the other way. What if I just gave you the reason? Take a look at number 4. Give the reason as segment, addition, postulate. What do you think number 4 is going to say? Well, we define what AC is. What do you think we should do next?
Define XC.
Well, hold on. Exactly. XZ is equal to XY plus YZ. So again, we're now defining our 2 segments here. Okay, now take a look at line 5. What's going on? What's changing?
You're
Say it.
you're I don't know if you're setting them equal to each other.
Not quite yet. What's really happening on line 5? Well, hold on. Okay, let's look at this from this perspective. What did we say about AB and XY on line 1? They're congruent. They're also equal on line 2, right? When 2 things are congruent or equals, what that tells us again, Amber, is that we can substitute them in, right? If 2 things are equal to each other, we can substitute them into or in place of one another. So we go from line 4 to line 5. All I've done is put AB in place of XY, and I put BC in place of YZ. And why can I do that? That's substitution property. So then what is number 6? How do I go and get AC is equal to Y or XZ? Sam,
Would it be substitution again?
why?
Because you're substituting,
It's addition.
you're substituting your AB plus BC equals AC.
Yeah. I'm taking this right here. And those two together equal AC, so I'm putting AC in place of AB plus BC.
Why did they switch that around instead of,
Well, because in order to do a proof correctly, you have to have it in the order that it's written. And technically, there should have been another line in there that's the symmetric property, but I left that out. All right, so then finally we have our equals, AC equals XZ. But what is it we have to prove? We don't have to prove that they're equal. We have to prove that they are congruent. So that means that I got to go from equals to congruence, and anytime we switch from equals to congruence, we call that the definition of congruence. And there you guys go. We just did it first proof. I don't know if that follows. Alright, so they're not horrible, are they? They're not great. They're not horrible. They're doable. You just have to think a lot. I know you guys don't like doing that. Here's another one. Okay. So we're given that A, B, C, and D are collinear. We're trying to prove that AD is equal to AB plus BC plus BD. First line of any proof, as always, the given statement. Alright, so AD is equal to AB plus BD. So AD is equal to AB plus BD. Sam?
segment addition?
Yeah, segment addition postulate. I'm taking my parts, adding them up to get the whole. That's segment addition postulate. Alright, so what is BD? Complete number 3. BD is what? Cheyenne?
BC plus C.
Okay, and what's my reason for stating that? Yeah?
Segment addition.
Segment addition postulate. So again, adding up the parts to get the whole. So what is line 4? The last line of your proof should always be which statement?
Your proof.
Your proof statement. So line 4, AD is equal to AB, BC, CD. And why is that? What did I do? Could be wrong. Or right. You can say quietly to me. Say it. Say it. What? Job, Tabitha, it's substitution. What did I substitute? So Cordell, what did I substitute there on line 4? In place of, well, in place of BD, I took the BC plus CD and I plugged it in right there for BD. So that's a substitution. How are we doing on this, guys?
Pretty good.
Are we at least up to a 3 out of 10?
Yeah.
Slowly making our way up to at least 5 out of 10. The goal for today is to get to at least 6 out of 10. Angle addition. What does that mean?
It's the same thing but with angles and stuff.
Yeah, so adding up the parts to get the whole. And so if I wanted to add up my two parts here, I'd have angle ABD plus angle DBC. And that would equal angle ABC. So adding up the sum of the parts equals the whole. All right, so this one, I'm gonna leave you guys to yourselves. Let you guys fight over it. There's the proof. Not going any slower.
Can't see.
Film this. Why is this still?
You know, I need to write it down.
All right, so here we go. There's your proof. Go at it. It says, I know the first one. It's given. 1 point. All right, so number 1 is definitely given. Oh my goodness, this is gonna get good. Mason says, I've got number 2. Def of Kong, which actually means what?
Definition of congruence.
Definition of congruence. Okay, good. I do need to actually make sure you guys know what depth of calling actually is. I was not doing my job any justice. All right, number 3. Kayla. No,
Ew.
not substitution. What do you think, Morgan? What do you think? That's the angle addition postulate. Hang at post.
Hang at.
Okay. Think about it, guys. Angle EDG. EDG. Angle 1 plus angle 2. Okay. And then FDH. I'm adding up 2 and 3 to get FDH. That's angle addition postulate. The sum of the parts equals the whole. Number 4. Number 4. Blake. That's substitution. Keanu. Number 5.
Angle postulate.
No, take a closer look at it. What changes from line 4 to line 5?
They get added together. So
What's missing?
well,
What changes?
well, the 2.
Yeah, well, so how do we get rid of the 2's?
I guess you subtract.
Subtract this. That's a subtraction property. They subtracted the angle 2 from both sides. And then number 6. This is a very tough one. We want to step up to the plate. Who's got number 6? Definition of Kong.
No, it's not.
Shoot.
Alright, I think what we're going to do is we're going to stop our notes.